Imagine you open your banking app and see a limited time offer. Option A, lock in a guaranteed bonus of $900 right now. Option B, take a 90% chance of getting $1,000 and a 10% chance of getting nothing. What would you do? Most people pause for a second and think, why risk it? I'll just take the 900. Now let me change only one thing. Suppose instead you owe money. Option A, accept a guaranteed loss of $900. Option B, take a 90% chance of losing $1,000 and a 10% chance of losing nothing. Now what do you do? And why does the same brain often answer these two questions differently? Here is the puzzle. In the first problem, many people choose the sure gain. In the second, many of those same people choose the gamble. That means people are often risk-averse for gains, meaning they prefer the sure option over an equal average gamble, but risk-seeking for losses, meaning they prefer the gamble over the sure option. But wait. Did the math change? Or did only the feeling change? If the numbers are mirrors of each other, why would our choices reverse? Let's test whether this is really the same problem in disguise. In the gain frame, the gamble gives $1,000 with 90% probability and $0 with 10% probability. The expected value, the average outcome you would get if you played the same gamble many times, is 0.9 times 1,000 plus 0.1 times 0, which equals 900. So the gamble's expected value is $900, exactly the same as the sure gain. Now do the loss frame. The gamble gives a loss of $1,000 with 90% probability and a loss of $0 with 10% probability. Its expected value is 0.9 times negative 1,000 plus 0.1 times 0, which equals negative 900. Again, exactly the same as the sure loss. So the arithmetic does not explain the reversal. If choice flips, something psychological is doing work. The standard economic answer is expected utility. What is utility? It is not money itself. It is a measure of how satisfying or valuable an outcome feels to the decision maker. The key idea is that an extra $100 usually matters more when you are poor than when you are already rich. So instead of averaging dollars, expected utility says, average the felt value of outcomes. That is already more realistic than raw expected value. But now ask the key question, if utility is the whole story, can it explain why people often prefer safety for gains and gambling for losses in these mirror image choices? Under the usual version of expected utility, if your utility curve is smooth and bowed inward, economists call that concave, which means each extra dollar adds a little less satisfaction than the previous one. You should generally dislike fair gambles on both sides. Why? Because the pain from uncertainty is still uncertainty. If a sure option and a gamble have the same average money payoff, a concave utility curve tends to reward the sure thing. So here is the non-obvious claim, ordinary expected utility can explain caution, but it does not naturally explain a clean reversal from caution in gains to gambling in losses when the two choices are simple mirrors. Let's prove that with one worked example. Suppose your current wealth is $10,000, and suppose your utility is the square root of wealth. That is a classic concave utility curve. First, the gain frame. A sure gain of 900 takes you to 10,900. The utility is the square root of 10,900, about 104.40. The gamble gives 11,000 with 90% probability and 10,000 with 10% probability. The expected utility is 0.9 times the square root of 11,000 plus 0.1 times the square root of 10,000, which is about 104.39. So expected utility prefers the sure gain. Now the loss frame. A sure loss of 900 takes you to 9,100. The utility is about 95.39. The gamble gives 9,000 with 90% probability and 10,000 with 10% probability. The expected utility is about 95.38. Again, expected utility prefers the sure option. So with ordinary concavity, you get caution in both frames, not reversal. Something is missing. So what is missing? Maybe people are not evaluating outcomes as final wealth levels like 10,900 or 9,100. Maybe they are asking a different question first: is this outcome above or below where I feel I started? That mental starting line is called a reference point. A reference point could be your current wealth, yesterday's stock price, the price you paid for a stock, the salary you expected, or even the deal you were promised 5 minutes ago. Once you introduce a reference point, $900 is no longer just $900. It becomes either a gain of 900 or a loss of 900. And that distinction turns out to matter enormously. Now we can name the core mechanism: loss aversion. Loss aversion means that a loss of a given size usually feels more painful than an equal gain feels pleasurable. In plain English, losing $100 tends to hurt more than finding $100 feels good. Notice how strong that claim is. It does not say losses are bigger in money terms. It says they are bigger in psychological impact. If that is true, then a sure loss can feel so unpleasant that people become willing to gamble just to avoid locking it in. Let's test that idea with a simple subjective value example. Suppose your mind treats a gain of $100 as plus 1 unit of feeling, but a loss of $100 as minus 2 units of feeling. The exact numbers are only illustrative. The point is that the loss side is steeper. Then a sure gain of 900 feels like about plus 9 units. A 90% chance of gaining 1,000 feels like 0.9 times plus 10, which is also about plus 9. So in gains, the sure option can feel especially attractive. Now look at losses. A sure loss of 900 feels like about minus 18 units. A 90% chance of losing 1,000 feels like 0.9 times minus 20, which is also about minus 18 on average. But psychologically, the gamble contains one emotionally powerful possibility: maybe I escape with no loss at all. That hope can make the risky option feel tempting. So once losses bite harder than gains reward, the reversal starts to make sense. This brings us to framing. Framing means presenting the same underlying outcomes in different ways so that people mentally code them differently. One frame says, "Here's what you gain." Another says, "Here's what you lose." The hidden trap is that people think they are responding to pure facts, when often they are responding to facts plus a frame. Ask yourself, if I say keep 900 of your bonus versus lose 100 of your bonus, are those emotionally identical? In total wealth terms, maybe. In lived experience, often not. So framing does not necessarily change the arithmetic. It changes which mental reference point becomes salient. Now move from thought experiments to markets. Why does an investor sometimes sell winning stocks too early, but hold losing stocks too long? One answer is loss aversion around a reference point such as the purchase price. If I bought a stock at 100 and it rises to 110, selling lets me lock in a gain. That feels good. But if it falls to 90, selling turns a paper loss into a realized loss, a loss I can no longer deny. So I ask, what if it bounces back, and suddenly I become willing to gamble? That is not just bad discipline. It is the same gain versus loss asymmetry showing up in the wild. So where does prospect theory enter? Prospect theory, developed by Daniel Kahneman and Amos Tversky, is a model of decision-making under risk built to describe how people actually choose, not just how perfectly consistent agents would choose. Its big shift is this: outcomes are evaluated relative to a reference point, not only as final wealth levels. And on that relative scale, losses loom larger than gains. That does not mean expected utility is useless. Expected utility is elegant and powerful. But prospect theory explains a pattern the standard model struggles with. The same person can play it safe when choosing gains and roll the dice when facing losses. But we are still missing one crucial piece. If gains and losses are felt relative to a reference point, and if losses hurt more sharply than gains feel good, then what does that value landscape actually look like? Is it a straight line? Is it curved? Where does the bend happen? And why does the zero line have so much power? That is exactly where we go next. In episode 2, the value function, we will draw the famous S-shaped curve behind prospect theory and answer the deeper question this episode has only set up. Why does the mind treat the same dollar amount so differently depending on which side of the reference point you are standing on?